So in this example, we've been given the function x squared e to the x over sine of x, and we've been asked to calculate dy by dx. We've been asked to calculate the gradient function. Now you should recall from previous videos or from looking through the notes that this is in the form of a quotient, because we have one function being divided by another function. So we're going to be using the quotient rule. But we should see that the function in the numerator is an x squared times an e to the x. So that's a product as well. So to actually find dy by dx, we're going to have to use the quotient rule, and we're also going to have to use the product rule as well. So let's remind ourselves about the quotient rule. So the quotient rule is when we have a function of the form u over v, and when we differentiate it, we find du by dx multiplied by v minus u multiplied by dv by dx, and it's all divided by v squared. So that's our quotient rule. And when you're doing a quotient rule, it's important that you correctly define your u and your v. Your u is your numerator and your v is your denominator. So for our example, we're going to set u equal to x squared e to the x. And our denominator is sine x, so that's what we're going to set v as. So v is equal to sine of x. And looking at the quotient rule, well, what do we need? Well, we need to find du by dx, so we need to find the derivative of this function here. And we also need to find dv by dx, so we need to find the derivative of this one here. Now, it's quite easy, I think, to find dv by dx. We just need to differentiate sine x, and we should know now that sine x differentiates to give us cos x. It's one of those results you'll find on a differential table. If we have a look at x squared e to the x, though, if we want to find du by dx, well, we're going to have to use the product rule, because we have x squared multiplying e to the x. So let's do a quick reminder of the product rule. If we have a function f times g and we want to differentiate it, it would be df by dx multiplied by g. So differentiate the first term, multiply by the second term, and then we add to that, it will be f times dg by dx. So it's plus, leave the first term alone, differentiate the second term. So if you look at our example, it's x squared e to the x. So if we differentiate the first term, we're going to get 2x, and then leave the second term. And then we're going to add to that, leave the first term, so that'll be x squared, and then multiply by the derivative of the second term. And if we differentiate e to the x, it stays as e to the x. So we've used the product rule to find du by dx. And we've got everything now. We have our u and v, and we have the du by dx, and we have our dv by dx. And we can now substitute these four functions into our quotient rule to find our dy by dx. So our dy by dx, what's that going to give us? It's going to be du by dx, so it's going to be 2x e to the x plus x squared e to the x multiplied by v, so multiplied by sine x, and then it's minus u, so it's going to be minus x squared e to the x, and then multiply by dv by dx, and dv by dx is cos x. And then it's all over v squared. All over, so everything gets divided by sine x all squared. So we'll write that as sine x squared. Now, that is our final answer. we can have a look and see if there's anything we can tidy up. And there is one thing we can do. We can see every term has got an e to the x in it. So what I'll do, I'll just factorise that out and tidy up our answer as far as we can. So if we take an e to the x out to the front, it will leave us with a 2x times sine x, so it will be a 2x sine x. And then it will be an x squared times sine x. And that's this first term dealt with. And then the second term, if I take out the e to the x here, it leaves me with an x squared times cos x with a minus sign. So it will be a minus x squared cos x. And that's everything factorised out of that numerator. So the only thing I have left to do is have the division by sine x all squared, which we'll write as sine squared x. So that's our final answer. That's how we differentiate x squared e to the x over sine x using a combination of the quotient rule and product rule. And that's our answer. Thank you for watching.